Hello all, welcome to another quick learning. Today we're going to be on part 2 of the SQL Codecademy tutorial. So if you missed part 1 and you want to catch that, I'll put the link in the description below. But otherwise, you can see we've completed that, and we're going to move on to the Learn SQL Queries section. So I'm going to go ahead and click that. And so we're going to have a little introduction here. In this lesson, we will be learning different SQL commands to query a single table in a database. One of the core purposes of the SQL language is to retrieve information stored in a database. This is commonly referred to as querying. Queries allowing us to communicate with the database by asking questions and having the result set return data relevant to the question. We will be querying a database with one table named movies. Let's get started. All right. So we should get acquainted with the movies table. In the editor, type the following. Select star. Alright, select star from movies. So SQL is not case sensitive, so you don't have to put in capitals for select and from and such. So you can see here, here's the results. You can see there's an ID, there's a name, and a genre. If I expand this, year, etc. Alright, I guess that's all I needed to do for that section. Let's go on. So select, previously we learned that select is used every time you want to query data from a database, and star means all columns. Suppose we are only interested in two of the columns. We can select individual columns by their names separated by a comma. So here they selected column 1 and column 2. To make it easier to read, we move from to another line. Line breaks don't mean anything specific in SQL. We could write this entire query in one line and it would run just fine. That is correct. Let's only select the name and genre columns of the table. Okay, so we're going to do select name, comma, genre from movies. And this semicolon just means it's the end of the statement. We'll run that. And we got the green check, so that means it was completed successfully. Now we want to include a third column. Edit your query so that it returns the name, genre, and year columns of the table. So that's pretty simple. Just put comma, year. Run that again. And I guess we got the green check, so that is correct. So you can see it returned those three columns that we suggested it to. As. Knowing how select works, suppose we have the code below. So we're doing select name as titles. Notice that titles is in the apostrophe quotation marks here. Can you guess what as does? As is a keyword in SQL, it allows you to rename a column or table using an alias. The new name can be anything you want as long as you put it inside of single quotes. Here we rename the name column as titles. It is important to remember that the columns have not been renamed in the table. The aliases only appear in the result. Alright, to showcase what the as does, select the name column and rename it with an alias of your choosing. Place the alias inside the single quotes, like so. Select name as, we'll call it movie name. Movie name from movies. Note in the result that the name of the column is now your alias. Right here, movie name. Edit the query so that instead of selecting and renaming the name column, select the IMBD rating column and rename it as IMBD. Okay. So it's called IMBD underscore rating. And we're going to call that IMDB. Okay. And there you go. There's the results. So we can go on to the next one. Distinct. When we are examining data in a table, it can be helpful to know what distinct values exist in a particular column. Distinct is used to return unique values in the output, filters all out all duplicate values in the specified columns. So you can see they have select tools from inventory, produces, you can see there's duplicates because some of the rows have the same value. If you put in distinct, then it'll just give you all of them down to distinct values. Filtering the results of a query is an important skill in SQL. It's easier to see the different possible genres in the movie table after the data has been filtered than to scan every row in the table. Let's try it out. Okay. So we're going to do select distinct, genre from movies. And we're going to end that and we'll run it. And you can see their unique ones are action, comedy, horror, romance, drama, and null for ones that don't have it filled in. Now change the code so we return the unique values of the year column instead. So we'll just go year there. And you can see they're not ordered. If we wanted to order them, we could do order by year. But it looks like there's quite a bit of different years here. Where we can restrict our query results using the where clause in order to obtain only the information we want. Following this format, the statement below filters the result set to only include top-rated movies. So IMDb ratings greater than 8. So you can see they're selecting all the columns from the movies table, and they're looking at the IMDb rating in particular and only selecting those movies where the rating is greater than 8. How does this work? Where clause filters the result set to only include rows where the following condition is true. This is the condition we said. The greater than symbol is an operator. Operators create a condition that can be evaluated as either true or false. Comparison operators used with the where clause are equal, not equal. In some cases, like in Oracle databases, you'll see this as not equal. Just to be aware of that. Greater than, less than, greater than or equal to, less than or equal to. There are some special operators that we will learn about in the upcoming exercise. Suppose we want to take a peek at all the not so well received movies in the database. In the code editor, type this, select star from movies, where IMDb rating less than 5. So it's going to be 0 to 4. I don't even know if there is a 0, but ooh, there's not too many actually. It looks like the lowest is actually 4.2. Edit the query so that it will now retrieve all the recent movies, specifically those that were released after 2014. Select all the columns using star. Okay, so we want after 2014, and we know that there's a year field. We're going to say year greater than 2014. Do we still want this rating? I guess not. So if you wanted the movies with a rating less than 5 and after 2014, you could do it this way, but it looks like they just want the ones that are after 2014. That's correct. Let's see. Actually, it's not real big, so they got Jurassic World and such in there. Blank. Blank can be a useful operator when you want to compare similar values. The movies table contains 2 films with similar titles, 7 and 7. How could we select all movies that start with SE and end with EN and have exactly one character in the middle? Well, you use the like operator, obviously. So you do where name, you put the like, and then you use the underscore that tells you that there should be one character there. So like is a special operator used with the where clause to search for a specific pattern in a column. Name like 7 is a condition evaluated in the name column for a specific pattern. SE underscore EN represents a pattern with a wildcard character. So the underscore means you can substitute any individual character here without breaking the pattern. The name 7 and 7 with the number 7 inside of it both match this pattern. Let's test it out. So basically they just want me to type what I just saw. Select star from movies, where name blank SE underscore EN. And then I will close that out. That was correct. Blank 2. The percentage sign is another wildcard character that can be used with blank. This statement below filters the result set to only include movies with names that begin with A. So you can see A and then percent means you can have any number of characters, even 0 after A. Percent is a wildcard character that matches 0 or more missing letters in the pattern. For example, a percent matches all movies with names that begin with letter A. Percent small a matches all movies that end with lowercase a. We can also use percent both before and after a pattern. So here we've got anything with man in it. So it'd be like Superman, Batman, Man of Steel, and like is not case sensitive, so yeah. So select star from movies where name blank percent man percent. We'll close that out with a semicolon. We'll run that. So we'll see the movies that we get here. Got Dead Man's Chest, Iron Man 3, Spider-Man, yeah, Pretty Woman, so even though it's part of another word, it still counts. Alright, let's try one more. Edit the query so that selects all the information about movie titles that begin with the word the. You might need a space in there. So to give you a little hint there. So begins with, so there should be no characters before this, so we don't need a wildcard character there. And they want the name the, so we need a space after that, and then we do this. If we put it like this, then you could have things that start with there or something like that. Anything that starts with those 3 letters would match. And that seems to be correct. Is null. By this point of the lesson, you might have noticed that there are a few missing values in the movies table. More often than not, the data you encounter will have missing values. Unknown values are indicated by null. It is not possible to test for null values with comparison operators such as equal and not equal. Instead, we have to use these operators, is null and is not null. To filter all movies with an IMDb rating, you would put in the where clause IMDb rating is not null. Let's do the opposite. Write a query to find all the movies without an IMDb rating. Select only the name. So we're going to do select name from movies and where IMDb underscore rating is null. So there is no rating. And we'll run that. And you can see we have some. So little strange, Star Wars The Last Jedi is not rated, Shaun the Dead, Dawn of the Dead. Between. The between operator can be used in a where clause to filter the result set within a certain range. The values can be numbers, text, or dates. The statement filters the result set to only include movies with name that begin with the letter A up to but not including J. So you can see where name between A and J. Or you can see where a year between 1990 and 1999. In this statement, the between operator is being used to filter the result set to only include movies with years between 1990 up to and including 1999. Really interesting point to emphasize again, between two letters is not inclusive of the second letter. Between two numbers is inclusive of the second number. So what that means is this will include 1999 when you do your where clause. But when you use letters, the movie starting with the letter J will not be included. All right, so using between operator, write a query that selects all information about movies. So we're going to do select star because they want all information from movies, where whose name begins with the letters D, E, and F. So movies between we're going to do D and F. Close that out with a semicolon. Oh, sorry, I want G actually. Didn't return any results. What did I do wrong here? Oh, so I put movies. I needed name. And I'm doing G because it's not inclusive of the last letter. Okay, there we got it. Remove the previous query. All right, that's pretty simple. Using the between operator, write a new query that selects all information about movies that were released in the 1970s. The 1970s, okay. Select star from movies, because we're doing the movies table still, where year, this time we're looking at between 1970 and 1979. Because with year it is inclusive, so it will include the 1979. Did I not put? All right, so you need the semicolon. You don't always need a semicolon with some of the database engines. All right. And sometimes we want to combine multiple conditions in a where clause to make the result set more specific and useful. One way to doing this is to use the AND operator. Here we'll use the AND operator to only return 90s romance movies. So here we did select star from movies, where year between blah blah blah, and genre equals romance. So the year between 1990 and 1999 is the first condition. Genre equals romance is the second condition, and combines the two conditions. So you see this is a Venn diagram. Since it's and, it only returns the results that meet both conditions. So in the previous exercise, we retrieved every movie released in the 1970s. Now let's retrieve every movie released in the 70s that also well received. I'm just going to copy this. So we're doing, I'm actually going to reformat it though. So we're, from the movies table, we're doing year between that, and then IMDb rating of greater than 8, and that's correct. Remove the previous query. Suppose we have a picky friend who only wants to watch old horror movies. Using and, write a new query that selects all movies made prior to 1985 that are also in the horror genre. Okay, so I'm just gonna delete this up to there. So we want years less than 1985, and we want genre equals horror. So again, since this is a number function, a number data type, sorry, you don't need these quotation marks. Since this is a string, you do need the quotation marks, and I need to close that out with a semicolon, so I'll run that. And it's thinking, it's thinking, it's thinking. And yes, we are done. And then OR is the other side of AND here. Similar to AND, the OR operator can also be used to combine multiple conditions in WHERE, but there's a fundamental difference. AND operator displays a row if all the conditions are true. OR operator displays a row if any condition is true. Suppose we want to check out a new movie or something action-packed. So you can see year greater than 2014 is the first condition, and genre equals action is the second condition, or combines the two. So anywhere where the two conditions are true, so it's all parts of both circles. So let's test this out. So we're going to do select star from movies where year is greater than 2014, or genre equals action. Close that out with a semicolon, run that. Now I was able to copy their code, great. Suppose we are in the mood for a good laugh or a good cry. Using OR, write a query that returns all movies that are either a romance or a comedy. So I'm going to change this here. Genre equals comedy. And then we'll copy this, paste it there. So we got comedy or romance. It's OR. It can't be both simultaneously, so AND would not work here. And that's correct. All right, now we're doing order by. That's it with WHERE and its operators. Moving on. It is often useful to list the data in our results set in a particular order. We can sort the results using order by, either alphabetically or numerically. Sorting the results often makes the data more useful and easier to analyze. For example, if we want to sort everything by the movie's title from A through Z, so we're ordering by name. Since we didn't specify whether it's ascending or descending, it automatically does ascending. Order by is a clause that indicates you want to sort the results set by a particular column. Name is a specified column. Sometimes we want to sort things in a decreasing order. For example, if we wanted to select all the well-received movies sorted from highest to lowest by their year, you can see it's ordered by year, and they put in the keyword descending, D-E-S-C, to make sure that it goes descending. So here, descending is a keyword used in order by to sort the results in descending order, high to low or Z to A. Ascending is a keyword used in order by to sort the results in ascending order, low to high or A to Z. The column that we order by doesn't even have to be one of the columns that we're displaying. By default, it's ascending, so you actually don't have to include that keyword. Suppose we want to retrieve the name and year column of all the movies ordered by their name alphabetically. Type the following code. I'm just going to copy this. So we're selecting just the name and the year from the movies table and sorting them alphabetically by name from A to Z. Taking a little bit of time, and there we go. Here, turn, remove the previous query, write a new query that retrieves the name, year, and IMDb rating. So I'm just going to put the IMDb rating here. Columns of all the movies ordered highest to lowest by their rating. Ordered by IMDb rating descending. Run. All right. Limit. We've been working with a fairly small table, fewer than 250 rows, but most SQL tables contain hundreds of thousands of records. In those situations, it becomes important to cap the number of rows in the result. For instance, imagine that we want to see a few examples of records. So they're selecting all the information from the movies table, but they're limiting to the first 10 rows. Limit is a clause that lets you specify the maximum number of rows the result set will have. This saves space on your screen and makes our queries run faster. Here we specify that the result set can't have more than 10 rows. Limit always goes at the very end of the query. Also, it is not supported in all SQL databases. That's a good note. I know that in Oracle databases this is not supported. So in Oracle you usually put in the where clause row num less than whatever you want to limit it to, some number, let's say 10. That's how you would limit it. Combining your knowledge of limit and order by, write a query that returns the 3 highest rated movies. All right. Select all columns. Select star from movies. Where? We don't need a where, do we? No, we don't. Order by IMDb rating, descending, and limit 3. And close that out. Is there a second part? Nope. So once this finishes, if it's correct, and then we can go on. There we go. Case. A case statement allows us to create different outputs, usually in the select statement. It is SQL's way of handling if-then logic. Suppose we want to condense the ratings in movies to 3 levels. If the rating is above 8, then it's fantastic. If the rating is above 6, then it's poorly received, else avoid at all costs. So you see case, and then when, the first condition, IMDb rating greater than 8, then it's going to give it the fantastic text. When it's greater than 6, it'll give it the poorly received, and then every other one is going to do avoid at all cost. So it stops running the code once it finds one condition that is true until it gets to the else, and then goes to the end. So even though all the movies that are greater than 8 are also greater than 6, they're going to show as fantastic. Each when tests a condition, and the following then gives us a string if the condition is true. The else gives us a string if all the above conditions are false. The case statement must end with an end. And the result, you have to scroll right because the column name is very long. To shorten it, we can rename the column to review, such as using as. Yes, so we learned the as keyword before to give it an alias of review. Let's try one on your own. All right, select the name column and use a case statement to create a second column that is, so we're going to do case when. Okay, so when genre equals romance, then we're going to call it chill. And then when genre equals comedy, we're going to call it chill, I guess, as well. Else, we're calling it intense. Then we have to finish it with end. And usually people indent this to know that this is all part of the same case statement here. Rename the whole case statement as mood. Take off that F. Okay. Give it your best shot. I never closed it out, and I never put from in there. From movies. Alright, so it looks like that's correct. So we're going to review here. Congratulations, what we've learned is select is a clause we use every time we want to query information from a database. As renames a column or table. Distinct returns unique values. Where is a popular command that lets you filter the results of the query based on conditions that you specify. Blank in between are special operators, and or. Combine multiple conditions. Order by sorts the results. Limit specifies the maximum number of rows that the query will return, and case creates different outputs. All right, I hope you guys were able to follow along and you learned something. Thank you very much.